Find the exponent, find the big number it's attached to. Find the exponent, find the big number it's attached to. Ms. Vila, could you just grab the door, please? Okay, a half to the negative 2. First, we need to deal with the negative exponent. What's our negative exponent rule? Goes under 1. How do we deal with a fraction when we have an exponent? How do we deal with a fraction when we have an exponent? Okay, so 1 squared, 2 squared. How do we divide fractions? Figure out x to the negative 1. Don't shout it out. Okay, first thing we deal with the negative exponent goes under 1. What do we do with a 1/2 to the imaginary 1? Leaves it as a half. Take the reciprocal, 2. 1/2 to the 0. 1/2 to the 1. 1/2 to the 2. Okay, so negative 2, 4. Negative 1, 2. 0, 1. 1/2. 2 1/4. Okay, there's y when the base is a fraction, it goes backwards. Okay, let's identify the transformations. The negative in front, is it inside the exponent or in the main equation? That makes it vertical. Because it's a negative, it is a xy goes to? The negative 4 in brackets, is it in the exponent or in the main equation? Is it a multiplication or an addition subtraction? 4 units to the? Okay, reflection first. So negative 2, 4 is going to go to? Negative 2, 4 goes to negative 2, negative 4. Negative 1, 2 goes to (0, 1 goes to 1/2 goes to 1/2 goes to, and 2 1/4 goes to Stop and ask yourself, did you do what you said you were going to do? Did we do a vertical reflection? Last graph in red, we're going to take every point and move it to the right. Again, don't get too caught up in these points that are really, really tiny. As long as it approaches the x-axis, we're fine. Write down the domain and range. Domain? Range? Or equal to 0? No. There's your domain and range. Okay, let's look at an application question. Okay, just read to read. Again, don't worry too much about it. Just read to get the context. Just like it's a little paragraph in a book. Okay, let's read to understand. What would you like me to highlight? Apparently nothing. That's what I've heard so far. Anything else? How do you recognize this as exponential? Because the variable is in the exponent. Part A just wants us to graph it, so grab your calcs. So 7.4, bracket 1.59, close the bracket. How do I do an exponent? The button, more specific.
Button above your finger.
So my finger was down here at that time.
So you're not clear. Button under clear. Up.
Maybe we could call it by its name.
Exponential button.
No, that would be y equals x. It's either called the hat key or calls a caret. So hat if you're a mathematician, caret if you're a scientist or computer scientist. Called a caret. No, because these are arrows. How do I get the variable t? Yeah, just x, normal variable. Okay, now they have told us information about the window. What is this 0 less than t less than 20? What's that talking about? It's talking about the x value, so mine's already 0 to 20. Come back. Y min we said is 0. What do you want to do for y max? Okay, I heard 20 and I heard 1 billion, so let's think about this. Years are at t, so we've already done that. It's given in the question. Okay, what do you think about the y max? 2010 would be a year, and we're not dealing with years. That was x. Okay, but it's given in millions, so we probably don't want to put a billion in there. So we want to put 100? Okay, let's graph it, see what it looks like. That's pretty. Now, because because we're not just doing a little sketch in order to solve it, we're actually given values and units. We're going to label the axes for this one. So what's along the bottom? What are we measuring and what's its units? Years would be the units. It's time. Okay, so if you're just doing a quick sketch to solve an equation and there's no context, you don't need to label. If you're given context like this question, you want to label your axes with what you're measuring and what the units are. Okay, question B, what are we trying to find? So is that an x value or is that a y value? That's a y value. So how do we find a y value on any graph if we know the x value? Okay, now usually we use it to find the y-intercept. Okay, do I want to put 2010 in?
2010 minus 1995,
Could you slow that down a little bit? So we know that the time is the years after 1999. If we want to go to 210, how many years is that? 15. Okay, so don't just type in 2010. You have to read the context. And to the nearest million. I'm putting that in brackets because no mathematician would ever write 1,000 million. What is 1,000 million?
Billion.
It's a billion, so how can we convert this to billions? 7 point. There's to the nearest billion, or to the nearest million. That was painful. Really? You just randomly shout stuff till it's right. Okay, what does C want us to find? Okay, so are we finding an X or are we finding a Y? We're finding a Y. We don't have another equation yet. How many times have we been solving equations graphically? A lot. How many methods are there? 2. Which method would you like to use? Okay, so what's the equation we're trying to solve? Okay, and how am I going to write billions and millions? Because it says it's in millions in the question, so I've got to convert billions to millions. We're trying to form an equation. That would not give us an equation because an equation needs a variable. So all the question is asking you to do is take the equation, set it equal to a billion. Would you like to use method 1 or method 2? Okay. I think you'd want to look at it first. Okay.
So why not have to be over
2,000s you offer?
1,500.
1,500? Okay, do you have a clear view of the intersection point? Okay, so let's sketch it out. What else do we need to do besides just sketch the graph?
Circle the
So this is the fourth kind of equation we're solving this way. Now what?
second function.
Yep, did that. Did that.
Enter. 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 10.6. Plus 19.5.
Really, you're adding your calculator to add 10 to 1995. What do we do with the 0.6? Just leave it y. Because it says in what year, so it happened in 2005. Okay, so there's an application question. It was slightly painful. Dig out your workbook because we're going to watch the video